All right, welcome everyone. In this video, we'll be focusing on calculating for quartiles in statistics. All right, and this will be our final video on calculating for quartiles in statistics. Now, in our previous video, we discussed that we have 5 types of quartiles in statistics. So the 5 quartiles, we have the Q0, we have the Q1, we have the Q2, we have the Q3, and then we have the Q4. And we mentioned that Q0 and Q4 are informal quartiles. Okay, good. And again, we mentioned that Q0 simply means, if we give you a data set, it simply means the minimum value in the data set or the smallest value in the data set. So the minimum value the smallest value in the data set, that is what we call the Q. So that's the smallest value in a data set. That is what we call the Q0. Q4 is also an informal quartile, and it represents the maximum value in a data set, or you can say the largest value. So when we give you a data set, the largest value is what we call the Q4. In some literatures, they will call this Q4 the 100th percentile. The 100th percentile. Is that okay? Then we come to the Q1. The Q1 is what we call the first quartile. Or you can also call it lower quartile. Or you can also call it median of the first half of the data. Median of first half of data. Again, you can call this one 25th percentile. Then we have the Q2. Q2 is what we call the median, or the middle number of the entire data set. Middle of the entire data set. Is that okay? Then we have the Q3. The Q3 is what we call the third quartile. The Q2, you can also call it the second quartile. Or you can call it the 50th percentile. That's the Q2. Then the Q3, we call it the third quartile. Or you can call it the upper quartile. The upper quartile. Or you can call it median of second half of data. The median of the second half of the data. Or you can also call it the 75th percentile. So that means that if we give you a data set, you watch the data set, the number that is small is what we call the Q0. The number that is large or highest or big or maximum is what we call the Q4. Now this Q1 simply means the first quartile or the lower quartile or the median of the first half. So when we give you a data set, depending on whether the data is odd or even, we have a way we can divide it into 2 halves. Now, if you're able to divide it into 2 halves, depending on whether it is an odd data or an even data, the middle number of the first half is what we call the Q1. And the middle number of the second half is what we call the Q3. Is that okay? And then the middle number of the entire data set is what we call the Q2. Now, when you get the Q1, It's also called the 25th percentile. That means that the answer you had for the Q1, okay, about 25% of the data is smaller than that number. That's the meaning. Again, if you get the Q3, it's also called the 75th percentile. That also means that the value you had for the Q3, about 75% of the data values are below that value you had for the Q3. If you get the Q2, what that also means is that the value you had for the Q2, about 50% of the entire data are below that answer you had for the Q2. The same thing applies to Q4. It also represents the 100 percentile. That means whatever answer you get or whatever value you had for the Q4, about 100% of the data is below that value in statistics. Okay, so now let's look at an example. Now, apart from this, you can also be asked to calculate for interquartile range. Interquartile range simply means the difference between the Q3 and Q1. So Q3 minus Q1. This is what we call interquartile range. Is that okay? And you can be asked to determine outliers. Okay? In quartiles, they can ask you to determine outliers. If they ask you to determine outliers, you just use this formula. We have the lower bound, and then we have the upper bound. The lower bound simply means it's giving you the lowest boundary. It's giving you a certain value that you would compare to the original data. Now, that value will tell you that, okay, if you get this value, any value in the data set smaller than the lower bound is a lower outlier. And if you calculate for the upper bound, and let's say you get a certain number, any value in the data set greater than the answer you had for the upper bound is an upper outlier. And the formula we use for the lower bound is K01 minus 1.5 times the interquartile range. And the formula we use for the upper bound is K03 plus 1.5 times the interquartile range. Okay, so now let's do some examples. So let's say we have these data, -1, 5, 8, 2, 5, 8, 10, 12, and let's say 180. All right, so this is a data set. Now pay attention, you observe that this data set is an odd data set. Now, in calculating for quartiles, there is a principle. You always have to arrange the data. Usually arrange the data in ascending order from the lowest to the highest. You realize that this data is already arranged in order. Is that okay? So we don't do any rearrangement. But if the data was messed up, we have to arrange the data set in ascending order. Now, the data is already arranged. Now, you can calculate for all the time in quartiles. Calculate for your Q0 first. Calculate for your Q0 first. Q0 is the minimum value in the data set. That's -1. Q4 is the maximum value in the data set. That's 180. Okay, then you calculate, the next you calculate is the Q2. Q2 is the median of the entire data set. You know, this data is an odd data. In an odd data, there will be a single middle number, a straight single middle number. So our middle number here is what? 8. So our Q2 is 8. Now, let's look at the principle in quartiles calculation. If we give you an odd data to calculate for the Q, so now we are left to calculate for Q1 and Q3. Now, if we give you a data like this to calculate for the quartiles, the Q1 and Q3, you first of all have to divide the data into two halves first. But the principle is, if the data is an odd data, look for the middle number and cancel the middle number. So you see, this is the middle number. Circle it and cancel it out of the data. Now, when you do this, the rest of the data, this is what we call the first half. And this is what we call the second half. This is called the first half. And this is called the second half. Is that okay? Now, Q1 says that, Q1 means that the middle number of the first half of the data. So you see, the median of the first half of the data, and that is 2. So KO1 is equal to 2. KO3 says that the middle number of the second half of the data, this is the second half of the data, that is 12. Then you write the 12 over here. Okay, so if we give you a data set that is an odd data, the principle is that look for the middle number, the median, and cancel it out of the data so that the data below it is the first half and the values below it is the second half. Is that okay? So KO1 is the median of the first half. KO2, KO3 is the median of the second half. Okay, let's assume the data was an even data. So -1, 2, 5, 8, 10, and 12. This is an even data. In an even data, remember that there would always be 2 numbers in the middle. Okay, in an even data, there would always be 2 numbers in the middle. So over here, these are the 2 numbers in the middle for an even data. The principle in quartiles is that for an even data, before you get the first half and second half, look for the 2 middle numbers, draw a line in between like this. You see, in the odd data, we identify the middle number and cancel it. In an even data, the 2 middle numbers, draw a line in between. Then this one become the first half. And this one become the second half. Is that okay? So it's 2 principles depending on whether the data is an even data or an odd data. If the data is an even data, you look for the 2 numbers in the middle, draw a line in between. Once you draw a line in between, the data below here is the first half. So KO3 will be the median. So this will be KO3. And this one will be, this one will be KO1. This one will be KO3. Is that okay? So this one is for an even data. But if it is an odd data, you identify the single middle number and cancel it out. Once you cancel it out, be careful you don't add this one to the first half and then come and say the remaining 3 is the second half. No. You have to identify the single middle number and you cancel it out. That is for all data. Then the numbers below would be the numbers below will be the first half. The numbers above will be the second half. All right. So now we can now continue to use the original data to go ahead with the other calculations we are supposed to do. So now we have the KO1, we have KO3. Now we can calculate for interquartile range. Interquartile range is equal to KO3 minus KO1. KO3 is 12, KO1 is 2, interquartile range is 10. Okay, so if the examiner asks you to calculate for the lower bound and the upper bound, or to identify outliers, once the examiner asks you in the question to identify outliers, all it means is you automatically have to calculate for the lower bound and the upper bound. So now the formula for lower bound is this. So the lower bound is KO1 minus 1.5 times the interquartile range. KO1 from the question is 2 minus 1.5 times 10. And that will give us negative 13. Now the upper bound. KO3 plus 1.5 times, so upper bound is KO3 plus 1.5 times the interquartile range. KO3 from the question is 12 plus 1.5 times 10. That will give us 27. Okay, so you see, this upper bound, if the examiner asks you to calculate for the outliers, what you should remember is the upper bound that will help you to know the outliers. And then the lower bound and the upper bound is what will help you to know the outliers. So if you calculate for the lower bound and you had negative 13, go back to the data. Is there any number in the data smaller than negative 13? So you check over here, you see The lowest number is -1. So it means on the lower side of the data, there is no outlier. Then you come to the upper bound, we have 27. Come to the data. Is there any number in the data greater than 27? And that is 180. So what it means is that on the upper side of the data, there is an outlier over there, which is the 180. Okay, so the boundaries, the lower bound and the upper bound, is helping you to identify the outliers. So if the examiner asks you in quartiles to identify outliers, what it means is that as part of your calculations, you have to calculate for the lower bound and also calculate for the upper bound. So you first of all calculate for the lower bound. Remember, if you get the lower bound, that is not the answer here. The -13 is not the outlier. You go back to the data and check. Is there a number in the data, especially at the lower side, smaller than the lower bound? So here you see -13. The smallest value here is -1. It's not smaller than negative. So it means at the lower side of the data, no outlier. But for example, if we had the lower bound to be, let's say, 1, if you check over here, you see we have -1. So it means we have one outlier, which is -1, at the lower side of the data. But here, our lower bound was -13. So it means at the lower side of the data, there is no outlier. Is that okay? Let's assume our lower bound, we have 3. What it means is that you go back to the original data and check. Is there any numbers there smaller than 3? So you see here, we have 2 and -1. So it means at the lower side of the data, we have 2 outliers. Then you write those 2 outliers. They will be outliers at the lower side. Then you come to the upper bound. Okay, but here we had -13. If you come to the upper bound, we have 27. Come and check the original data. Is there any value in the original data greater than the 27? And that is 180. So it means at the upper side of the data, the outlier there is 180. Then you write. So therefore, there is one outlier, which is equal to 180. So the outlier is the 180. Okay? And in statistics, we can ask you to use your calculation to draw a box plot. Now, in a box plot, this is how it looks like. The box plot will look like this. Or you can call it the risky plot. So on the box plot, this is how it looks like. So here is the Q1. Here is the Q2. Here is the Q3. Then you do a line over here and do bar like this. Then you write interquartile range will be here. Then here is where we write the Q0. Here is where we write the Q4. Okay? So this Q0 is the minimum value in the data set. This Q1 is the lower quartile or the first quartile. Okay? Or the Q1. Then the Q2 is the median. Okay? Which is the second quartile. Then the Q3 is the upper quartile. Okay? Or the third quartile. Then the Q4 will be here. Is that okay? Then if there are any outliers, so for example, this calculation, our Q0 is -1. So you write the -1 over here. Our Q1 is 2. So here will be 2. Here will be 2. Our Q2, which is the median, is 8. Here will be 8. Our Q3 is 12. Here will be 12. Our Q4 is 180. Here will be 180. Then our interquartile range is 10. So here is 10. Is that okay? Great. Then you would have the outliers. We don't have, so no outliers over here. No outliers over here. But here there is one outlier. And that is the 180. Is that okay? Great. So that is it. So let's do another example. Let's do another example. So when we give you a data like 4, 8, 2, 3, 5, 10, 201. And let me add negative. Let me add negative 40. 1, 2, 3, 4, 5, 6, 7, 8. So negative 40. So this is an example. All right, so this is a data set that we've been given. So 1, 2, 3, 4, 5, 6, 7, 8. So this is an example of an even data. Now in quartiles, the first thing you do is you check whether the data is in order. If not, you have to arrange the data. So here, let's arrange the data. We are going to have negative 40 will come first. That's the smallest. From there, 2 will come. From there, 4 will come. From there, 3 will even come. Then our 4 will come. 5 will come. 8 will come. 10 will come. And then you have 2, 0, 1. So 1, 2, 3, 4, 5, 6, 7, 8. Our data is intact. We have 8. Now, the next thing you are going to do, I told you, is you always have to calculate for Q0. So Q0 is the minimum value. Here is negative 40. Q4 will be the next. That's the maximum value in the data set. That is 200. So Q0, Q4 is very easy to calculate. This is the minimum value in the data set. This is the maximum value. Then the next is Q2. Q2 means the median of the entire data set. Q2 is the normal median you already know in statistics. So Q2 is the median. So we have 1, 2, 3, 4, 5, 6. Then we have 2 numbers in the middle. This is an even data. So principle in statistics, if you are given an even data, there will be 2 numbers in the middle. And the median is the average of those 2 numbers. So 4 plus 5 divided by 2, that will give us 4.5. Okay, then we now calculate for our Q1 and Q3. Q1 means that now before you calculate for the Q1, remember the principle. When you are given an even data and you are to calculate for Q1 and Q3, first of all, divide the data into 2 equal halves. This is an even data, so identify the 2 numbers in the middle. Here is 4 and 5. The principle says draw a line through like this. Once you draw a line through, this part of the data is the first half. This part of the data is the second half. Now, Q1 says the median of the first half. So the middle number. So the first half, surprisingly, the first half too is even. So the median of the first half, that means 2 plus 3 divided by 2. So 2 plus 3 divided by 2. Then we are going to have 5 divided by 2. That will give us 2.5. Now, Q3 means the median of the second half of the data. Surprisingly, this one too is even. The second half of the data too is even. There are times the second half of the data can be odd, like this. But here, the second half of the data too is even. 8 plus 10. So 8 plus 10 divided by 2. And that will give us 9. So it means that our Q1 is 2.5, Q3 is 9. Now we can calculate for our interquartile range. Interquartile range, what is the formula? Q3 minus Q1. Q3 is equal to 9 minus Q1 is equal to 2.5. So our interquartile range is equal to 6.5. Now, when you get the interquartile range, the examiner can ask you to determine outliers. Determine outliers. Now, remember that if we give you a data set, an outlier simply shows extreme values in the data set. And before you calculate for outliers, you have to calculate for what we call lower bound and upper bound. So you write the formula. Lower bound is equal to, so the formula for lower bound is Q1 minus 1.5 times interquartile range. Q1 from the question, the calculations we did, we have Q1 is 2.5 minus 1.5 times interquartile range is 6.5. That will give us minus 7.25. Then let's do the upper bound. The upper bound KO3 plus 1.5 times interquartile range. KO3 from our question is 9 plus 1.5 times interquartile range is 6.5. That will give us 18.75. So now when you get this lower bound is not the outlier. The mistake a lot of students make is that when they get this lower bound, they write this for the examiner as the outlier. No. Go and use this answer, the lower bound, to compare the data. So the lower bound, check. Is there any value in the data set smaller than this negative 7.25? If you check over here, you see that it's minus 40. Is that okay? So what it means is that this minus 40 is an outlier at the lower side of the data. Then you come and check the upper bound to the answer you get. You had 18.75. You ask yourself, is there any value in the data set greater than this 18.75? If you check over here, it's 201. 201. So it means that in this data set, there are two outliers. And again, the examiner can even give you the data set and ask you that, okay, how many outliers are there in this data set? Here, the answer is 2. If you calculated and used the upper bound and lower bound, and let's say you had 201, it means the outlier is what? Is just 1. That one, the outlier will not be 20. The examiner is asking you how many outliers are there in the data set. So here is 2 outliers. Let's assume the outlier, we had only this. It means 1 outlier. Is that okay? So remember that when the examiner asks you to determine outliers, automatically you have to calculate for the lower bound and also calculate for the upper bound before. All right. Okay, so let's go over it for the last time. I mentioned that if we give you a data set like this, first of all, arrange the data. Now, in arranging the data, here we are going to have negative 40. We would have 2. We would have 3. We would have 4. We would have 5. We would have 10. No, we would have 8. We would have 10. And we would have 201. So the first thing you always have to do is you have to arrange the data in order, usually in ascending order. Now, after arranging the data, you now have to calculate for KO0 and KO4 first. KO0 is the minimum value, that is negative 40. KO4 is the maximum value, 201. Then you calculate for KO2. KO2 is the middle value in the data set. So here we have this. So we have 2 values in the middle. Is that okay? We have 2 values in the middle. So this is 1, 2, 3, 4, 5, 6, 7, 8. This is an even data. So we have 2 values in the middle. 4 plus 5 divided by 2. That will give us, come again, 4.5. Then we now calculate for, we are left to calculate for KO1 and KO3. Now, for an even data, before you calculate for the KO1 and KO3, you have to identify the first half and the second half. The principle is that look for the 2 middle numbers, draw a line in between. So you draw a line in between. Once you draw a line in between, the values here are the first half. The values here are the second half. So these values here, first half, these values here, second half. So you see over here, we have 2 and 3 in the middle. KO1 says that the median of the first half of the data and the median will fall between these 2 and 3. So KO1 will be 2 plus 3 divided by 2. And that will give us 2.5. KO3, the median of the second half of the data. If you come and check, you see this is the second half of the data. KO3 means the median of the second half. The middle number of the second half of the data. So you see, this is the second half. The middle numbers will be 2. 8 plus 10. 8 plus 10 divided by 2. That will give us 9. Then we calculate for the interquartile range. The formula is KO3 minus KO1. Now, what is KO3 from the question? From 9. So 9 minus KO1 is 2.5. That will give us 6.5. That will give us 6.5. Now, if the examiner goes further to ask you to calculate for the determine outliers in the data set, once you see determine outliers, what it means is you mandatorily have to calculate for the lower bound and upper bound. So you write the formula. Lower bound, and the formula for lower bound is KO1 minus 1.5 times interquartile range. And then the formula for upper bound. So you interpolate into the formula. KO1 is 2.5 minus 1.5 times interquartile range is 6.5. That will give us minus, then the upper bound KO3 plus 1.5 times interquartile range. Now remember that for the upper bound you use plus, and the upper bound you use, the formula goes with the KO3. For the lower bound we use minus, and for the lower bound the formula goes with the KO1. There are at times students make mistake with the formulas a lot when they are calculating for the lower bound and then the upper bound. So for the upper bound, KO3 plus 1.5 times the interquartile range. KO3 from our computation is 9 plus 1.5 times interquartile range is 6.5. That will give us. So now, remember that when you get the lower bound, that doesn't mean this answer is the outlier. So the answer you had for the lower bound, go back to the original data and compare. Go and compare it to the original data. Okay, so for example, here is negative 7.25. Is there any value here smaller than the negative 7.25? Over here is minus 40. So the minus 40 is smaller than this. So it means that this minus 40 is an outlier. So this is an outlier at the lower side of the data. Then you come and check the upper bound. What did you get? We had 18.75. You ask yourself, is there any value in the data set greater than 18.75? If you come and check over here, it's greater than, this is greater. 201 is greater than this. Okay, 10 is smaller than this, but 201 is greater than the 80. So it means that this is also an outlier. So in this data set, there are 2 outliers. So 2 outliers. Then you write, therefore, outliers are negative 40 and 201. So these are the outliers, negative 40 and 201. Let's do another example, which is an odd data. That will be our last example. So we give you an odd data. So example 2. So 5, 2, 8, 10, 15, 49, 207, this example, negative 50. Okay, so this is our data set. So 1, 2, 3, 4, 5, 6, 7, 8. Let me add one more to make it a bit interesting. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, so this is an odd data. Excellent. This is an example of an odd data set. Odd data. The first example we looked at was an even data. Now for an odd data, the same principle. First of all, arrange the data In quartiles, you first have to arrange the data. Now, in arranging the data, we are going to have negative 50. Then 1 will come, 2 will come, 5 will come, 8 will come, 10, 15, 49, and then 207. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. So our data is intact. Now, after arranging the data, the first quartiles we calculate is the Q0, Q4, and then Q2. That's the first thing. Anytime you give you quartiles question, always do this one first. So Q0 is the minimum value. And over here, that is minus 50. Q4 is the maximum value. Over here, that is 207. Q2 is what we call the median of the general data set. And remember, this is an odd data. In statistics, when we give you an odd data, the median will be a single middle number. So here we have this, this go, this go, this go, this go, this go, this go. The median is 8. So the single number in the middle is 8. Then now we are left with Q1 and Q3. Now, when we give you an odd data in quartiles, the first thing you have to do is identify the middle number, which is the Q2, and step on it and, in fact, cancel it out of the data. Do this. Once you do this, the values here is the first half, and the values here makes up the second half. Now, in exams, we can give you a data set like this, and we will tell you, write out all the values of the first half. Is that okay? What that means is that if you don't know how to do this, because you see, if you don't know how to do this, you can't calculate for Q1 and Q3. So if the data is an odd data, you step on the middle number and cancel it. In fact, we don't even need it. So you cancel it. Then the rest of the values is the first half. The rest of the values is the second half. Now, Q1 says that the median of the first half of the data, or the middle number of the first half of the data. Interestingly, in this data set, the first half of the data is also even. The first half of the data is even. So here, you would have this. So we have 1 and 2 in the middle. So Q1 is equal to 1 plus 2 divided by 2. And that will give us 1.5. Q3, we are going to have 15 and 49 in the middle. So Q3 will be 15 plus 49 divided by 2. Now, Q3 means what? Q3 means the middle number of the second half of the data. The middle number of the second half of the data. So the middle number, that will give us, come again, 32. So what that means is that our Q1 is 1.5. Our Q3 is 32. So now we can calculate for our interquartile range. Interquartile range is equal to Q3 minus Q1. So our interquartile range will be Q3 is equal to 32 minus Q1 is 1.5. That will give us, come again, 30.5. So this is our interquartile range. Now, if the examiner asks you that, okay, this is the data, determine outliers, automatically you have to calculate for lower bound. The formula for lower bound is Q1 minus 1.5 times the interquartile range. What is the Q1? Q1 from our question is 1.5 minus 1.5 times interquartile range is 30.5. That will give us minus 44.25. Then you now come and calculate the upper bound. Now the upper bound, the formula is Q3 plus 1.5 times the interquartile range. Now what is Q3 from the question? 32. From our calculation, Q3 is plus 1.5 times interquartile range was what? Interquartile range was 30.5. So our upper bound will also give us 77.75. Now, when you get the lower bound, it doesn't mean this answer is the outlier. A lot of students, when they get here, they conclude that this is the outlier. And they also conclude that what they had for the upper bound is the outlier. No. What you had for the lower bound, go and compare it to the original data. Go and compare it to the original data. What you had over here, compare it to the original data. Is there any value here in the original data that is smaller than this? So if you check the original data, you can see clearly that this negative 50 is smaller than negative 44.25. So it means this is an outlier. Then again, you ask yourself that, okay, the upper bound, the answer you had, is there any value in the original or the arranged data set that is greater than this? If you check over here, you can see clearly 207 is greater. So this is also an outlier. So you see, we are getting an outlier at the lower side of the data. And we are also getting one outlier at the upper side of the data. Is that okay? And when you finish, you can use this to do the box plot. So this is how we do the box plot. So you draw your box like this, or sometimes they call it the whiskey diagram or whiskey plot. So here is where, this is the median. So here is where we put the K0. So K0, what did you get? 50. You write the 50 over here. K01, what did you get? Here is where we put the K01 here. So K01 is 1.5. K02 is the median. So K02 is 8. K03 is the upper quartile or the third quartile. So K03 is here. K03 is 32. You write the 32 here. Interquartile range, we write it here. Interquartile range was 30.5. 30.5. Then the K04 is here. We write the K04 over here. K04 we had 207. So 207. Then if you identify any outlier, so here we had an outlier. The outlier was 207. You can write it here. And then at the lower side of the data, we had one outlier, which is negative 50. Sorry, here is negative 50. So here, the minimum value is negative 50. Remember, it's not positive. So here we have one outlier, negative 50 over here. You can also write. So the outliers will be here. Here. Is that okay? So this is how we go about it. All right, that is fine. So I think this will be the last example that we will look at.